about recursion. Recursion seems a very complicated term. Whenever I started learning programming, I couldn't understand recursion in Java or Python. Similar, like I could never, as of now, also I could understand uh, pointers in C. So today we will elaborate about recursion. What actually the real-time use case? So basically, when we ask for the recursion, the examples we get is Fibonacci series, factorial, you know, reverse, sort of things, right? But those are not the which we are going to use in while doing a real-time project works while doing our work time. So today we'll first discuss what is recursion, why do we need recursion, and what are the real-time scenarios that is helpful to make things faster using recursion. Let's get started. Before heading into video, please take a moment to subscribe, like and share so that others will get benefited from this explanations. Let's get started. Okay, I will take the screen and I'll start explaining. Recursion. We have seen recursion, right? We have seen functions. Functions nothing but a piece of code which we will make it as a modeler and keep it aside. Whenever it is required, we just use it. If there is any modification, we will go on modifying this method. So that particular method, wherever it is calling, will be get applied over there. That's why we use function. But there are scenario where assume there are files. Okay, I want to do a single operation in file, but it will be recursive. Example, I have a folder, I have a file. Inside I have folder, I have file, okay, and agar I have a some other folder, and inside folder I have one more folder, and inside folder I have one more folder. But if you see, the operation is same, right? That means I need to go to a folder, I need to extract file, I need to go to this folder, I need to extract file, and I need to go to this folder. Assume there are 100 folders. So what I'm going to do? So assume there is a simple use case where I have to go to each folder and retrieve that .csv file. Okay, and I have 100 recursive folders. Recursive means -r, means that inside folder there is a folder, and that folder there is one more folder, and one folder there is one more folder. So in such scenarios, we will use recursion. Now let's start with a simple use case. 10 to 1. Okay, add 10 to 1. One way you just minus for loop, you do it. Assume there are 10,000. Yeah, for loop you can do, but the operation is similar, right? You don't have to do other thing. For such scenarios, we use recursion. And there is one more real-time use case using JSON. I will explain to you once we discuss the simple functions. Let us remove this, and first we will discuss about Java. Alright, so okay, I have a piece of code here. So basically what we are doing here, sum of integers. So the use case is, if I give 10, it has to count till 0. If I give 100, it has to count to 0. Now I have written the function here. What I've written? Sum of all integers, take n will be 10, and first I have to put a condition, n is equal to 1, n is equal to 0. We in recursive function, the breakpoint is very necessary. So what I'm telling is, if I give the n value is 1 or 0, return that value. Don't call this method, right? So I'm breaking point is here. Now what I will do, I will write n is equal to 0, return n, else n plus what I'm using here? Sum of all integers. You can see I'm calling sum of all integers. That is what happened. 10 will come. 10 is equal to 1, 10 is equal to no. Then it will come 10 plus 10 minus 9. 10 minus 1. 10 plus 9. Next it will come. Again it will come. This is coming. So 10 minus 10 minus. Again inside internally it will call this minus 1. 9 plus 9 minus 1. 8 plus 8 minus 1. 7 plus 7 minus 1. Like that till it reaches 1. If it reaches 1, it will break this point. That's how recursion works. Recursion work means it takes the value, it just checks that 1 is equal to 0 and it comes here and we think, okay, now what happened? So if example it is 10, so 10 will go here and it is 10 is equal to 1. No, the condition is false. It comes here. 10 plus 10 minus 9. That means 10 minus 9 is 1. It will become 11. And it again calls minus 1. Then it will keep calling until this condition. So inside what it is there, it reaches 1 or 0. Definitely it reaches once and it breaks the function. If in case in recursive, if the breaking point is not there, then it will be the function will be run infinitely. So we have to make sure that is what is the requirement. Why do we put as a list of directories inside directories? If it is a JSON inside one node, parent node, child node, and child is also parent of another child. So a parent is there, so it's like a grandfather, father. For father is child and child is again a father and mother. And there is inside nodes. In such scenarios we have to think to implement recursion, and also we have to think that what is my breaking point, how I'm going to end this loop of the recursive function. Okay, so what we will do, let's call it over here. I'm just calling this sum and let me print this. Okay, the sum of integers is, alright, sum. Let's run this. So okay, there are no errors. Let us run this. Okay, you see that the sum of integer is 55. So similarly, we'll try to write one more thing. It's called, just me copy paste this, factorial. Sum is n plus n minus 1, but factorial it is multiplication, right? So it takes n and it takes n, but instead of plus we will do n into n minus 1. So 5 will come, 5 into 4 into 3 into 2 into 1, then again 4 into 3 into 2 into 1, 3 into 2. It keeps multiplication and it keeps printing. So same thing, I'm going to print it over here. Factorial, the fact, and let's print this. All right. So n into n minus 1, 5, 4, did I print this? So I have to change it. Okay, sorry, I have to put this function here. I need to call this function. Okay, I'm calling here. Okay, let's print. Okay, you need to see that we get the factorial. Now the same concept we will see in Python. Python is also similar concept. See, if it is a sum, then n minus 1. If it's same factorial, Same thing, I will use here factorial n into n minus 1. Simple. What I have to use is I have to use this method here. So concept is same, just we if loop, else loop, if and else and similar thing. The fact value and fact of 10. Just press run and you can see that it calculated. But in real case, in real time scenario, we don't get the recursive factorial and all, right? For the recursive, we will get a real time concept like list directories, and one of the most in real time case which I faced and which I have solved using recursion is retrieving through JSON. I'll show you that. Let me this one, and I will uncomment this. Just comment this. Now we'll try to explain one use case and then we will discuss how we are going to solve. So I have a JSON here. You can see this is a JSON. Inside there is an array. There is an JSON file. It have the address. It have a context. It have this one. Okay. So what I'll do, this is one node. It goes into in another node. This node may have another node. Another node may have another node. So JSON looping, right? So it's a parent. Parent can have a child, and child could be a parent of another thing. So it will be like a if it's like a tree structure. So these type of things we can use recursion to solve it. Show it how I'm using this. All right, so here I'm just taking simple JSON file path, and I am calling here, making an object. I'm calling here itest. Let's go here. So prefix is nothing but I'm just creating a space, nothing else. So you can just ignore it, just a space. That's why to print a format. So what I'm doing is, if instance of JSON object. So what is basically JSON? I'm converting to JSON object. When we see that API testing, we will understand more about what is JSON object, those details. So we're converting JSON objects and we are taking key set. So JSON object have all these values like key set, get JSON object. This is a JSON library. So it takes the key and send key and value. So we are printing key. Once we print the key, we are getting the key value. If you see the same function, we are again calling this function. So the next key will go here. This is an object. It again brings the key. This function loops until there is a JSON object. But if in case when you go into this function, if it is a JSON array, then this condition will be called. So basically what we are doing, we are just printing, going to the one node to another node. In this type of scenarios, we have to use recursion. Assume there is a one, right? There is an age and parent have another age. So we want to do calculate the age of a parent and a child. But parent has again child. Child is again a parent, and that parent has again child. So in such scenarios, we have to use a recursion. One thing we have to check that is the regression can apply, can make it solve easily with less number of code. And another thing is we need to understand that what is the breaking point for this recursion. If you see here, the breaking point is what? If there is no JSON object, it's going to break, right? If it is not object and that has been emptied, this is going to break. So something we need to have a condition which is going to break the loop. So I'm going here. Okay, let me print this. You can see the JSON object has been printed. I'm just printing the JSON object, but to print the iterate in the JSON object, I am using the recursion. Just go into the one object, go inside another object, inside another. I'm just giving the sample use case, but there are complicated use case where you have to use the recursion. Mostly the recursion could be used in API automation, where the response we need to validate that it has a parent, child, and then any operations we need to do. The recursion is the best method to apply. Thanks everyone. Thank you very much. So this were I'm going to bring more interesting and I'm going to simplify more complicated topics. And please like, share, subscribe. Thank you everyone. Bye bye.